So we talked last time about this whole cross product thing. So let's see if we remember how we find the cross product of two vectors. So if we say that u is going to be the vector 1, 2, say -3, and v is going to be the vector, let's say -2, 1, 0. Then we can find a new vector, u cross v. And do you remember how we do that? So the first row of our determinant, our 3 by 3 determinant, we're going to write ijk. Yeah, so u has to come next. And so the order makes a difference because when you change the rows and determinant, it changes the sign of the result. So u cross v is going to be the opposite sign as v cross u. And what we get then is going to be the -2, 1, 0. Okay? And we're going to use expansion by minors because we want to, and we'll always expand along the first row because we want to keep that ijk thing. So remember that there's a sign pattern that goes with expansion by minors. So we're going to go plus, minus, plus. And so this will be I times its minor. And I's minor we create by crossing out the row and the column that I is in. And that resulting 2 by 2 determinant should look like 2, -3, 1, 0. Then we're going to get a minus because of the sign pattern j. So it's going to be a minus j. And then j's minor, we cross out the row and the column that j is in. And the 2 by 2 determinant that remains is 1, -3, -2, 0. And then we go plus from the sign pattern k times k's minor. And we delete the row and the column that k is in. And the resulting 2 by 2 is going to be 1, 2, and -2, 1. Okay, here. So 2 by 2s, we go down minus up, so that's going to be 0, minus a -3, makes that a positive 3i. And then a 0 minus 6 is a -6, times a -j makes that a plus 6j. And -2 times negative, so we have 0 minus 6 is -6.
Oh, yeah, it's minus 8.
And then the minus negative makes it a plus 6. Okay?
I hate negative sign.
Yeah, I know, too many negatives. So 1 minus a -4 is 5k. So let's see, our u cross v vector, u cross v is going to be a new vector, 3, 6, 5. Okay. Now, let's talk about the properties that a cross product vector has. So the claim is that this cross product vector is perpendicular to both of the original vectors. And we can see this because if we take, because I think it's cumbersome to keep writing u cross v, I'm going to just call it w. So we can see that u dotted with w is going to be that 3 plus 12 minus 15 is 0. And so that's because its dot product is 0, that means that u and w are perpendicular. And if we take the dot product of v with our cross product vector that we call w, then we're going to get, let's see, a -6 plus 6 plus 0 is also 0. And so we can see that our vector v is also perpendicular to that cross product vector. So what we're getting is we have these two vectors in space, wherever they may be. We think of them in standard position. So wherever they may be in space, we imagine putting them at the origin. And what we're getting is a vector that's perpendicular to both of those vectors at the same time. So this follows what's known as the right-hand rule. So when you take u crossed with v, so you imagine that you put the u vector, you put your right hand out, like you're going to shake hands with somebody, and you consider the u vector to be where your fingers are, and the v vector to be where your palm is. Does that make sense? So then u cross v, and then you stick your thumb up, your right hand thumb up. That's where the u cross v vector goes. That's the, because if you have two vectors in space, then the perpendicular vector could come out this way, or it could go down. So u cross v is always going to go where your thumb is on your right hand when u is your fingers and v is your palm. So then if you turn it around and you go v cross u, now you want to then turn that around so that the v, you can hurt yourself here, so your v is going to be now where your fingers were, and your fingers are now where your palm was, and your thumb is now pointing in the direction of v cross w. So it goes up in one order and down in the other. Does that kind of make sense? So that's called the right-hand rule. Okay, so let's talk about some properties of this cross product. Did we do this? How did we do this?
We did the u cross v equals negative v cross u, and then the v cross u is parallel to v and u.
Okay. Okay, so and there's some more though. So properties of cross products. So the one is, like we said, that v cross w is perpendicular to u and v both. And we showed that. We know that, we talked about that if you change the order, so v cross w is the negative of w cross v. V cross w is perpendicular to, it should be w and v. Bringing in another vector that we don't know. So v cross w, you change the order, you change the sign. And that again tells you that change in direction. That's the geometric interpretation. So the third one is you can kind of do this like distributive property, u crossed with v plus w. So remember, v plus w, you're adding two vectors, getting a new vector, and then in turn crossing that with u and getting a vector that's perpendicular to those. So you could also get that same vector by crossing it first with v, crossing it with w, and adding those results together. It's not totally obvious when you think about it, but it works. Now we have said that u is perpendicular to v when their dot product is 0. Well, now we have that v is parallel to w if and only if v cross w is the 0 vector. Everything becomes zeros. That make sense? Should we take a look at one real quick?
Yeah.
So to be parallel, we know they have to be multiples of each other. So let's say that v is going to be the vector 1, 2, 3. And a vector that would be parallel to that, we could say is 2, 4, 6. Okay. Does that make sense? So V crossed with W would be I, J, K, 1, 2, 3, 2, 4, 6. Now, you remember we talked about this before? We haven't done very much with this. This is more in the lines of matrix theory, that when you have two rows that are multiple of each other, the determinant's always going to be 0. So if you look at that, it won't take very long to see that you're going to get 2, 3, 4, 6. That's 12 minus 12 is 0. And likewise. So this is going to end up being 0, 0, 0, 0i plus 0k plus 0, or 0j plus 0k. Okay? So that means they're parallel. Kind of interesting. Huh? 5 is the crazy one. So the magnitude of this cross product vector is equal to magnitude of v times the magnitude of w times the sine of theta, that angle in between them. And I don't know how well versed you are in formulas, but that is actually the area of that
Yeah, the first part of the
parallelogram.
Yeah.
Yeah. So area equals 1/2 base times height. So you are getting a triangle. So if here's your theta, we'll say here's the base, there's the height. So that's our formula, 1/2 base times height. So we know from SOHCAHTOA that, so if I call this just C, then the sine of theta is going to be opposite over hypotenuse. And so the hypotenuse is going to be C sine theta. And so what we have then is this becomes 1/2 base times C times sine theta. So that's the area of the triangle. So if we multiply both sides by 2, then what we're really getting is the area of that parallelogram. And that's exactly what this is saying there. So that is the area of the parallelogram formed by our two vectors V and W. Kind of crazy. So there's a geometric interpretation. You got this vector V, got another vector W. Their cross product is going to be a vector that is perpendicular to both of those, and its magnitude is going to be the area of that parallelogram. So again, looking at that, you're kind of looking at the extremes. So if we have these two vectors, if I push that vector all the way around so that it lies on top of W, now we have V and W are collinear. They're parallel to each other, right? That's that part that we just set up here. And now their cross product vector is going to have a length of 0. So that's the one extreme. How much area can you enclose with two vectors? Well, if the angle between them is 0, you got nothing. So the biggest you can do is when they get to be a right angle. And they're going to be perpendicular. And anything in between will, so it's kind of like this vector, kind of grows or shrinks depending on what that angle is in between them. That also gives us a way, interestingly enough, to find sine theta. And this is going to look a lot like what we did, only not quite the same, to find cosine theta. Because cosine theta, you remember, maybe, I hope, maybe not. So cosine theta, we know, is
You
That's u dot v over magnitude u, magnitude v. Now, sine theta, you can see, is going to be magnitude of that cross product vector over, and here again we have magnitude v, magnitude w. Kind of interesting, isn't it? Okay, so this, now we're going to go back and revisit this idea of finding an equation of a plane given, 3 points on the plane, because the hard part was trying to find a normal vector to the plane. But now we have a great way of finding normal vectors to planes or to anything else. If we got 2 vectors, we can find a vector perpendicular to them. So if we have 3 points in a plane, we can create 2 vectors from those 3 points. We can take their cross product of those 2 vectors to get a vector perpendicular to both of them, which will then make it perpendicular to the plane. And then we're on the way to finding the equation of the plane. Oh, crazy. So use, have like a defect in my Hagoromo chalk.
Uh-oh.
I think I have tears.
You know, we never watched that Hagoromo chalk video.
You've never seen that?
You've never seen
Our
it?
class didn't watch it.
Oh,
We didn't.
you must
Oh, I
have.
watched it.
So use cross products and find an equation of a plane. So remember, we're looking for this ax plus by plus cz equals d, and this, we call it that normal vector, is going to be that a, b, c. So we need a vector that's perpendicular to the plane so we can steal it to use as the coefficients for our plane. And we know this d is going to be equal to, it's going to be that, all that stuff there, where our xyz is going to be a point. So we're going to have to find a point so we can find the d, but that won't be hard. Okay, so we want to so first, find a non-zero vector perpendicular to the plane containing P, so one point is 103, and a second point Q is 250, and the third point R is 314. So this is how we're going to find our normal vector. Okay, how do we do this? PQ, PR. So make sure they have the same initial point. So we're going to find PQ, and we're going to find PR. Good. So PQ is going to be 5, negative 3. And PR is going to be 211. Okay, so now we have PQ and PR. So visually, we've got this plane that's containing these 3 points. We got P, we got Q, we got R. So we got a vector PQ and another vector PR. So to find a vector perpendicular to PQ and PR, we're going to find the cross product.
Does it matter which one we cross with?
It doesn't, because remember, they're going to follow the right-hand rule. So one of them is going to point up and the other one's going to point down. But they're interchangeable. They're still both good normal vectors for the plane, which is what we're going to have next, just to get the equation of the plane. So either one's going to be perpendicular to both of the originals. So if we go PQ cross PR, got I, J, K. The PQ is 1, 5, negative 3, 2, 1, 1. Remember your sign pattern. Plus, minus, plus. So the I times its minor, which I believe is 5, negative 3, 1, 1, minus J times its minor, which I believe is 1, negative 3, 2, 1, plus K times its minor, 1, 5, 2, 1. All right. So, cross product, down minus up. 5 minus negative 3 is going to be 5 plus 3. It's going to be 8i. 1 minus negative 6 is 1 plus 6 is 7. The negative j makes it a minus 7j. 1 minus 10 is a negative 9k. So our vector that is perpendicular to both of the starting vectors is 8, negative 7, negative 9. In agreement? Because that's part A, we've done that. Okay? So then part B is going to be find an equation of the plane containing PQ and R.
Don't you put in the vectors?
Yeah, well, so we've got a vector. This is going to be our normal vector. That's going to be our A, B, C, and AX plus BY plus CZ. To get the D, we need a point on the plane, and you can use any one of those 3 points.
Wait, when I plugged it?
What's that?
Oh wait, never mind. Yeah, 6 instead of 9. It's probably why.
Okay, so B is going to be find an equation of the plane containing P, Q, and R.
Which point did you use? P.
Should get the same D, right, no matter what, in theory.
Yeah.
Minus 9.
I want to save P, Q, and R. So we're going to go 8x minus 7y minus 9z equals D. So if I use 103, it looks like 8 times 1, that's going to be 0, minus 9 times 3. So 8 minus 27, negative 19.
Yes.
Does that work no matter what we use, I hope?
I thought you just said
16 minus 35, 24 minus 7, 17, minus 36, and negative 19 all the way around this company. So our answer then is going to be the 8x minus 7y minus 9z equals negative 19. Kind of cool? Okay, find the area. So can we now, I don't think I need that, find the area of the parallelogram with sides PQ and PR. Find the area of the parallelogram with sides PQ and PR.
It's just the magnitude of it. Yeah, it's the magnitude of it crossed.
There's no way that's it.
It is not simple.
It really is. What is that? 64 plus 1 plus 0?
So we know it's going to be the magnitude. Too much arithmetic. 64, 49, 81. Let's see. These two, that'll be 50 and 80 is 130. 194.
He did it the simpler way.
I know.
Why don't you always find the hard stuff?
I don't think we're going to be able to do anything with that. I think
I
that's the end of the story.
really hope not.
I say we just do the B.
You okay with that?
Live and let live.
Move it along. Okay, so that's pretty much all the new stuff. Let's see if we can practice a little bit. So I think it's trying to come to the board. So let's let U be the vector 1, 0, negative 2,
It told me this would happen.
and V is the vector negative 5, 2, 4.
What should we use today?
And we
Use the purple one, use the pink one.
use the dot product to show that U cross V is perpendicular to both U and V.
Okay, so we got to cross this.
Secondly, find sine theta, where theta is the angle between U and V.
When I heard practice, I became such a happy lad. Let's see, that's gonna be 4 plus 14. Does that sound just make you happy?
It
Just
does,
to-
it is a very musical, nice sound. Let's say.
Alright, I want to see what you get for your vector. Okay, I'm just gonna call that W.
Fourth minus 10.
Oh, yeah, wait a sec, is that a minus minus?
What?
Minus 5 minus. Oh, this is a minus. Yeah, that's what about. Oh, look at 6. Plus. Minus J. Oh, yeah, you're right, you're right. You're right.
Negative, negative. Come on.
You're right, you're right.
And then it's just 2.
Four, 6, 4, 2K.
So now you can use the dot product.
Yeah, on U and B. Let's correct that. Okay, so
You got that with the
you divided with W, bro. It's just 4 plus 0 minus 4 is 0. And if you divided with W, it's just negative 20 plus 12 plus 8 0. And check, check. Find sine of theta, where theta is the angle between U and V.
zero. Oh god, that looks like mine. My arms hurt.
Oh Lord, you're one of those people. Disgusting. Get that out of here. Let's throw the same nice equation up.
You do your zeros clockwise or counterclockwise?
I do like we gotta find sine, which is just this, where 16 plus 36 plus 4 over magnitude of this, which is really just square 5. And 5, 4,
I don't have a
16
calculator.
under 45.
You got one?
Square
Yeah,
of
but
5
you're using
over
a calculator.
square.
I'm sure you
We got lots of disinfectant.
I'm sure, but I don't want extra work.
Oh, not a problem.
That's what I'm hearing.
36. Extra work.
16 plus 36.
Okay, so this is really just 3 square roots of 5. So is that going to be just that? Oh, Mr. Street, that's a negative 5.
Oh, I missed that. Okay.
Ah!
Is that-
Victory!
16 is 35.
What are you doing? Hold up. Colton. 25 plus 16. Slow down. 45. Which is really just what, Colton? Reduce it, trust me. It makes life a lot easier.
I don't know what you're using. I would,
Colton, reduce it.
that doesn't make it any better.
Yeah, it does. It's square root of 56 or 15.
Now when I'm putting that into a calculator, I'm gonna just do it the way that I do it. Like that.
You're gonna do it the wrong way, is what you're saying, bro?
That's not wrong. Those are equivalent.
You know what's weird? When I'm on the board, I
That's
do
what
my
Alex
logs.
did.
Yeah, but Alex also used a calculator.
That's what you're supposed to do.
What am I doing wrong here? Not product, counting it with negative 462 dotted with.
Wait. Oh, it's a.
Because
positive
this is
6.
4 minus
Six.
10, which is negative 6
Six.
minus 5.
Okay, that changes
So,
everything.
so on my homework, I do one coherent box, but when I'm on the board, I do 2 different ones. I'm wrong. You do circles clockwise.
Yeah.
Like a wrong person.
Sine theta was the magnitude of our cross product vector. Or magnitude u, magnitude v. So the magnitude of that is going to be 16, 36, and 4. And we got square root of 5 and square root of 25, 4, and 16. So that's going to be 40,
I looked at all of the
56.
AP Calc stuff, and I was
We
like,
got
I can't believe this was ever hard to me.
20, 45.
Yeah,
I messed up my
Oh.
phone over him yesterday.
4 times 14. And this is 5 squared of 5.
You reduced
So
it.
5 squared of 5 is 5. 15. Is that what you got
So if you
for
make it reduced it.
sine theta?
Yes, we all have different forms.
No.
No, him and Alec have the same form. And then
We
I
just
have
didn't-
We
partially
just didn't
reduced
simplify
it.
it, yeah.
You have reduced.
So on the test, will you like dock us points if we don't show that IJK step? If we just, like what I didn't write the IJK, I just did it
You
as like a
never
2x3.
Anything yet. You did what now?
I did a 2x3 instead of the 3x3 to
Yeah, I'm
IJK.
gonna have a problem with that.
You will?
Yes.
Okay.
What if I just give you the answer?
That's
Is that gonna cause
that will get
problems?
1 point.
Yes.
I got a feeling it's be worth more than 1 point.
Dang.
To get that 1 point.
You gotta show the IJK.
form first.
Okay, we all agree other than how little work we can get away with showing? So that's a given. A is 0.01 negative 3. And B is 0.2 negative 2. 2 negative 2.
AB and AC.
That's negative 9.
Make sure you get the points right, Austin.
Yeah, no, negative 201.
Two, negative 0,
Negative 1. Can we, let's see, find,
Well, I'm just get started on it, please.
Did that.
Did you really? I'm so proud of you.
use cross products to find the area of triangle ABC.
On the area of ABC.
Triangle ABC.
I'm making sure our negatives match up.
-6 minus.
Okay, so can we jump from right here to the minus I plus I? Do you want us to show like the plus I?
Oh, no, yeah, you just, oh, you're gonna go
Like, can we just go from here to writing that?
the IJK? I'm okay with that.
Okay.
If you don't get it right, you're gonna lose
Well,
some.
If you
It may
made
cost you
one
more
to
than
write
if
out
I saw
I.
what led to
Oh,
it.
that whole, yeah,
Yeah.
we don't wanna do that. -6 minus 6.
Ayo.
Hmm.
What the sign hell am I doing?
I don't know, but it's negative 12.
I know.
Mm,
4 minus 12 is.
minus -6. Really?
Yep. Find, okay, so we just gotta take the magnitude. 144 plus 64 plus 64. Oh, okay. So that's just 144 plus 144. Nope. So that's gonna be what? 272. Maybe 272?
Yep.
Anyone know that off the top of their head?
162492.
Did you divide it by 2?
Is it? Yeah,
It's the triangle.
Oh, yeah, I did not. Thank you.
So it's 8.246.
I'm just writing it like that.
It's like a contest to see how little you can write down.
We all wrote down about the same amount.
Yeah. Except I need to put this in the radical, so the radical doesn't just show up at itself.
Negative 12i, is that
Yeah.
right? Minus 12 is 8J.
Yep.
Doing the minors part's pretty easy now. You just might have to look at the different sections.
And you know what the sections are, so it's pretty just smooth.
And we're trying to find the area, so we want the magnitude of that.
Over 2.
Over 2, yeah, because that's parallelogram.
Oh, that would make it a lot easier then.
Not really, you just have a minus on all of your work.
So is what we're covering on the 8 feet is?
No.
What's that?
Is all this gonna be on the 8 feet?
No, none of this is on the AP.
It's just gonna be big brain in it with stuff they didn't even know.
Yeah, but this will help us with lunch.
Did you get 6 square root of 2?
To help us when we're grocery shopping.
Of course.
You get 6 square root of 2?
He reduced it.
Yeah, something like that.
Well,
Oh, no, I did wrong.
well,
I was like, he reduced that in his head.
I mean, you were 0.24 off, so you were pretty close.
How about we can, why, 144, it's 12 times 12. I mean, it's gonna work, is it, 128, 144?
I woke up late, so I didn't get into my spreadsheet, so I have 225 from the sandwiches.
You can take a 4 out and you do 4 squared to 17.
4.
And then make it 2 squared to 17 if you cancel the 2.
I'm gonna keep it real cheap.
That's
I ain't
it.
gonna do that on the test.
I'm gonna do that. I'm just gonna get the
Dude,
calculator.
you don't
You
even
just get
do
squared to
this.
17?
No, it should be squared of, no.
2 squared.
Yeah, 4 squared to 17 over 2. So you could take 2 4s out of that.
Okay.
You take 16 out, so it's 16 times 17.
All I'm saying, bro. I don't remember what I was gonna say.
Okay. Well, that looks great. Questions on that? We'll steal a few minutes and start on the next lesson.
Blazing on.
Yeah, we can kind of. 'Cause I don't know, it's gonna be a long one next
Really?
one.
Yeah,
I like switching it up.
I'm just ready for it, I don't know.
I had one, it was when he like, I think it was last year. He had this piece of white chalk he let me use, dude. Oh, it just flowed across the chalkboard, didn't pop. It's so smooth, so nice. How far did your other class get? How far did they get?
They haven't had it yet.
Oh yeah, 'cause
See, I haven't seen him in a while, yeah. So that, we're good now for home number 18. So I'm gonna jump and start leading into what we're gonna do tomorrow, because it's a lot to do for one day tomorrow. So we're gonna do what's called partial fraction decomposition. So this will lead to, we're just gonna do the partial fraction decomposition part. We'll circle back to this later because it's actually a technique of integration. So it's a way to integrate some things that we can't do a different way. So I think you'll be able to see it a little bit. But the idea is a partial fraction decomposition. So partial fraction decomposition looks something like this, where you take, say, 3x minus 4 over, say, x squared minus 2x. So now where this is going to come in the calculus part is we'll be integrating this. So we'll be trying to integrate it. And it just doesn't fit anything nicely with anything we've done before. So it turns out you can, if you notice that you can factor that into x times x minus 2, we can break this into 2 over x plus 1 over x minus 2. So we get a constant over one of those linear factors and a different constant over the other linear factor. Now we always go the other direction. We take two things, we want to add them together. You multiply top and bottom by x minus 2, multiply top and bottom by x. You get a common denominator and you end up with this. What we're doing is going the other direction. So we're going to take this and pull it apart. And so how to do this is known as partial fraction decomposition. So the idea is this integral eventually, not today, not tomorrow, but eventually, this integral we wouldn't know how to do. We don't have any good techniques that will work. But if we can split it into this, and these are equal to each other, these integrals we can do. Okay, and so that's where we're headed. That's the goal of partial fraction decomposition, and that's a technique of integration called partial fractions.
Is there like a step in between that?
Oh, there's a lot of steps. In
It
between, yeah.
doesn't just like.
No.
like that.
That's not by inspection. No. You don't look at it and go, oh, yeah, of course, it's that.
I was
No.
like trying to figure out where you're
How
coming
to
from.
get there is the challenging
I
part.
was confused how the 2 came from. I was like,
So you should know this one.
So what happens though, now first a little bit of theory behind this. So when you take p of x over q of x, so this is our function, and it is some rational function. So you have a polynomial over a polynomial. Now, if the degree, we want the degree of p to be strictly less than that of q. And if they're not, So if P has a degree bigger than or equal to Q, we're going to long divide first. Right, so if you had something like, x squared plus 1 over x minus 2, we can't do partial fraction decomposition with this. We'd have to divide this into that, and then the remainder will be degree smaller than x to the first. And that's what we'll work with. The other part we can integrate fine, because it'll just be polynomial. And then this, the remainder, we would then work with. So if the degree is not less than that, we long divide first. If not, long divide first. So we want to look only at these rational functions where the degree of the numerator is strictly less than the degree of the denominator. Now, there's still more to go there. So, I don't know how far I'm going to get on this. So, we have our P of x over Q of x. Now, the Q of x, that's where we're going to direct our attention. We factor that as much as we can over the real numbers. So it turns out that any polynomial can be factored into linear factors, maybe to different powers, or irreducible primes, something like irreducible quadratics, and maybe that's to the third power or something like that. So what we're going to do is we're going to factor that denominator as much as we can. When you do that, you'll never have an x cubed that survives. Anything that's third degree or higher can be factored more. Now, maybe it's really challenging to do that, but it can be. So you can get it down to linear factors, or some quadratic factors we can't factor over the real numbers. If we allowed imaginaries, we could factor that as x minus I, x plus I. But we don't use imaginaries because we're talking calculus eventually here. So we may have to live with some irreducible quadratics. Okay. Now, this is really awkward to say. I don't know if I can do it in a minute. So you have these various linear factors. And some might be to various powers, whatever they are. Then you've got some irreducible quadratics. So what we will do is we'll break this down. Well, we'll talk about this more next time, but we'll break it down into, we'll go constants over the linears, and then linears over the quadratics. We'll talk more. And then it'll be fun to figure out how to solve for all those constants.
Oh, yeah, we gotta talk about that, don't we? Yeah.